Okay guys, welcome back to section 3 of our integral calculus series. In this video we are going to be looking at a couple of more examples. Now in the last video we saw some examples where it is possible for you to factor out something from the numerator for the fact that when you differentiate the denominator you're not going to get the numerator. Now if this is the first video you're seeing, I'll suggest you move down to the other videos I have on this playlist so that you understand what we're actually looking at. Okay, I'll put a description to those videos. I'll put a link rather in the description so that you can just go through them before you come to this video. But if you've been watching those ones, fine, you're fine and good to move along with this example. And again, if you're already into integrals, you've done a couple of things on integrals, then I think you should be fine. Now we're looking at this form of integration where when you differentiate the numerator, the denominator rather, we're asking are you going to get the numerator. Now in other videos, in the videos prior to this, we saw cases where once you differentiate the denominator you're going to get the numerator. We also saw cases where when you differentiate this you're not going to get a numerator, but you could factor out something for the numerator. Now if I differentiate x squared plus 4, what I'm going to get is 2x. And you agree that for the fact that what I have here is 2x, there is nothing I can factor from the numerator to get 2x. Well, generally there is nothing, but there's a way you could do that. You can say you want to factor out something out of that. It's possible, but let us assume that it is not possible. So what I'm going to do here is this: whenever you have this kind of situation, since your result is 2x, what you need here is a 2. You need a 2 in front of this. How do you do that? All you need to do is to multiply this thing by the 2. So that's what we do here. We multiply by 2. But once you do this, you've gone you're altering the law of mathematics. Why are you altering that, or how are you altering that? This expression is not the same thing as this expression any longer. So if I integrate this, it is not going to be the result as if I had integrated this. Okay, so for me to make sure that that law is still in place, that this expression, these two expressions are still the same thing, after multiplying by 2 you still divide by 2. So you have 1 over 2 outside. That means you're dividing by 2. Okay, so now if I differentiate the denominator, I'm going to get a numerator. So my result is going to be ln of the denominator with a half in front of it. So I have something like this: ln of the denominator, then I have the half in front of it, which you could also make, if you want to take it one step further, take the half to be the power you have here, and that's what you have in this example. Okay, let's take one more. Let's say we have this expression x squared all over x cubed plus 3. If I differentiate this, I'm going to get 3x squared. Okay, for the fact that I'm getting 3x squared, I need a 3 in front of this. So right now I don't have that 3. So what I need to do is to multiply by the 3. But as usual, like I did in the previous case, for the fact that I multiply by 3, you divide by 3, or you have 1 over 3 in front of it. So now if I integrate this, I'm going to get ln of the denominator, and I have the 1 over 3 in front. Take the 1 over 3 to be the power, and then you have this as the final result. Okay, so that's it guys, for this form of integration. This form is when you're looking at fractions. In our next video we are going to be looking at the form that is in product. What do we actually do? So that's it guys, and I'll see you guys in the next video. Bye bye.